So in this video, we're going to talk about naming of covalent compounds, of acids, and then also of hydrates. And we are going to actually start out with talking about naming hydrates because it's very similar to what we've been doing with naming ionic compounds. A hydrate is just an ionic substance that has absorbed water. So you will know that you have a hydrate. Let me write hydrate. Because it'll have a chemical formula and it'll have a dot in the middle, and then maybe a coefficient, and definitely H2O. It'll only have the coefficient if there's more than one water molecule. So it might say 2H2O or 3H2O, but it will never say 1H2O because we don't show a coefficient or a subscript of 1. And if you have a hydrate, you're just going to take the normal ionic name, following whatever naming rule you need to follow to get that name. And then you add a prefix indicating how many water molecules you have, and then the word hydrate. So let me show you what I mean here. So if we have NaCl dot 4H2O, we would start out by naming NaCl just following the appropriate naming rule for naming simple binary ionic compounds. So sodium and chloride. I just changed the ending on chlorine to IDE. And then I need to add the hydrate part. So the prefix that means 4 is tetra. Think about Tetris with 4-sided shapes. Tetra, and then I add hydrate. And that is all one word. So the correct name for NaCl.4H2O is sodium chloride tetrahydrate. Let's do one more, example number 2. And let's this time do one that has a transition metal. So I have NiCl4 dot H2O. So this time I need to follow the transition metal naming rule. So I have nickel, and I need to figure out how to balance my charges. I know that each chlorine has a charge of -1, and I have 4 of those -1 charges, which gives me a total negative charge of -4. So I know I need to balance that with +4 on the nickel. So this will be nickel 4 chloride. And since there's no number here, I know that it's just one water molecule, and my prefix for 1 is monohydrate. So this is nickel 4 chloride monohydrate. So the names are kind of a mouthful, but it's really not that difficult to name hydrates if you know how to name ionic compounds. Moving on, let's talk about naming covalent compounds, and I'll do that in purple. So let's talk about naming binary covalent. And in case you're checking, this is naming rule number 5 on your guide to chemical naming sheet. So we know something is binary covalent if there are no metals, if it is not an acid, and then if there are just 2 elements, or 2 element types. And to name a binary covalent compound, we use our set of prefixes, those binary covalent prefixes that you needed to memorize when we were determining formulas. So we take the prefix plus the name of the first nonmetal, and then as our second word, we put another prefix to indicate how many of the second nonmetal we have, plus the root word of our nonmetal, plus ending in IDE. So let's try an example of this, because this the sequence up here makes it look more confusing, I think, than it actually is. So example number 1, let's do S2O6. So we have 2 sulfurs, so our prefix that means 2 is di, so I'm going to put disulfur. And then as a separate word, I'm going to put a prefix that means 6, which is hexa, hex, and then we don't actually put the A with oxygen, we just put hexoxide. Change that ending to IDE. So S2O6 is disulfur hexoxide. And then example number 2, we have SO4. And so we have one exception to this prefix on the first nonmetal, and that's if there's only one of it. So we don't put monosulfur here. Instead, we just put the word sulfur. And then we definitely put the prefix on the second word, always, always, always. And that prefix meaning 4 is tetra. So this will be tetroxide. We knock off that A when we have oxygen. And last but not least, let's talk about naming acids. So we have binary acids and we have ternary acids. And we've already talked a good bit about the names of acids because it's necessary to understand the naming rule to be able to figure out the chemical formula. So this probably is pretty familiar, but we're going to go through it anyway. First we have binary acids. Binary acids. And the way that we know we have a binary acid, which by the way is naming rule number 6 on your sheet, the way we know we have a binary acid is if there's no metal, it starts with hydrogen, and it only has 2 types of elements. And so for binary acids, we use that prefix hydro to indicate that it is an element bonded to the hydrogen. And then we put the root of that element name, and then we put ic on the end of that. And then as a separate word, we put the word acid. So it's hydro plus the root, ic acid. So let's try this out. So it's example number 1. Let's do HBr. So bromine, just the element bromine here. So we need to start out with hydro. And then we take the root of bromine, which would be brom. We change the ending to ic. So hydrobromic. I'll underline the acid naming rule parts of this. Hydrobromic. And then we add the word acid. Hydrobromic acid. And then example number 2, we have HCl. We start off with hydro to indicate that it's the element chlorine. We take the root of chlorine, which is chlor, change the ending to ic, and add the word acid. So we have hydrochloric acid. And I will say that there are a limited number of common acids. So go through your periodic table, and for each of the halogens in particular, write out the name of their acid and just say it out loud to yourself several times so it starts to sound familiar to you. We have hydrobromic, hydrochloric, hydroiodic, hydrofluoric. There's a limited number of acids though, so just go through, write the names, and then say them to yourself to help you remember the rule. And then lastly, we have ternary acids. Ternary acids. And it's the same sequence as over here. There's no metal. It begins with hydrogen. But instead of having just 2 types of elements, we'll have more than 2 types. And for ternary acids, the naming rule is actually simpler. We just take the name of the polyatomic, so polyatomic And then we change the ending to either ic or us, with the ending changed. And then we add the word acid. So if the polyatomic ion ends in 8, we change the ending to ic, I-C. And if the polyatomic ends in ite, we change the ending to us, O-U-S. So let's do this real quick. Example number 1, we have H2SO4. So this is the sulfate ion. And so we're going to change the ending to ic. So we're going to have sulf. And sulfate and sulfite are actually a kind of weird root. The root is sulfur, sulfuric, and then we just add the word acid. So it takes some getting used to these abnormalities. It's just like the English language. We have a language and we have rules, but there are still all sorts of annoying exceptions to the rule. So not sulfic, but sulfuric acid. And that's why I really do recommend just writing the correct names and saying them so you get used to the abnormalities of the language. So number 1, H2SO4 is sulfuric acid. And then example number 2, we have H2SO3. So we have the sulfite ion this time, sulfite. So this is going to change to O-U-S. And so we have sulfur, the root, sulfurous, and then add the word acid. Sulfurous acid and sulfuric acid. So this gets easier just with practice. You will get used to the language, and eventually we will all be able to speak the language of chemistry.